Alright, these are the notes for Algebra 2, Section 7.6, actually the third part of our notes for 7.6, and it is the second part of solving logarithmic equations. Now, we kind of mentioned this in the last video, but because the domain of the logarithmic functions is usually not all real numbers, we have to check for any solutions that don't actually work, or extraneous solutions. For instance, if we had ended up with x equals -1 or something like that, right, and we plugged it in to log of -1, well, that doesn't work. We can't take the log of -1. It doesn't exist. So that would be an extraneous solution. Now, the way that shows up is usually in problems that require us to solve quadratic equations. So let's look at an example here. Now, we want to solve the log of 5x plus the log of x minus 1 equals 2. Now, immediately you should see that I have two different logarithms here being added together. Normally, to get rid of a logarithm, I would want to exponentiate both sides. Unfortunately, I am not able to exponentiate both sides until both of these logarithms are combined into one logarithm. Now, we remember our product property of logarithms, right? The product property of logarithms says that if I have two logarithms being added together, I can combine them into one logarithm where I multiply what I'm taking the log of. So log of 5x plus log of x minus 1 becomes log of 5 times x minus 1. Right? I multiply them together. Now that I've done that, you can see I have one logarithm. And as long as I have one logarithm, I can exponentiate each side. Now I'm going to exponentiate each side by giving them both a base of 10, because the base of the common log is 10. So I'm going to have 10 to the log of 5x times x minus 1 equals 10 to the second. And of course, 10 to the log base 10 cancels out, leaving us with 5x times x minus 1. On the other side, 10 squared is just 100. From here, now that we've gotten rid of the logarithm, it's gone, poof, disappeared, we're just looking at a regular equation. So let's do all the stuff we would normally do to solve a regular equation. For instance, the first thing we would normally do is distribute here to get rid of the parentheses. So let's do that. We'll distribute and get 5x squared minus 5x, because 5x times x is 5x squared. 5x times -1 is -5x. And that still equals 100. Now you should notice that I'm looking at a quadratic equation. Right? This is a quadratic equation, right? Because I have a square term there. So now, since this is now a quadratic equation, I have a better blueprint of how to solve it. Every quadratic equation has to be in standard form, which means I need to subtract 100 from both sides to get it equal to 0. So that's my job. Subtract 100 from both sides, gives me 5x squared minus 5x minus 100. Now I could try and factor this quadratic expression, but it would be crazy because I'd multiply 5x squared times -100. I'd get -500x squared, and I'd be looking for to add together to get -5. It would be a mess. So instead, I want to divide out any common factors. And in fact, we do have one common factor, and that common factor is 5. All three of these guys share 5, right? 5, 5, and 100 is divisible by 5. So I'm going to divide each side by 5. Now, 0 divided by 5 is 0, right? Yeah. Over here, 5 divided by 5 is cancels out, so we just get x squared. Negative 5 divided by 5 gives us negative x. And negative 100 divided by 5 is negative 20. Now I want to factor this, which means that my result should be a couple of binomial expressions. And that means that I'm going to have to do some factoring here. If I multiply x squared times negative 20, I get negative 20x squared. I would need the factors of negative 20 that add up to negative 1. And those factors would be negative 5 and positive 4. Negative 5 times positive 4 is negative 20. Negative 5 minus 4 is negative 1. So these are my two factors. Notice I did kind of eschew the box method here because I knew my first terms had to be x and x because this is x squared, right? X times x is x squared. I knew that all I had to do was find the factors of negative 20 that added up to negative x. So negative 5 and 4. Now what that means is that x either equals, I'm going to change color here. That means that x equals 5 or x equals negative 4. One of those two. Or both. Who knows? Could be either, either or. But we need to check for extraneous solutions. We need to make sure that our solutions actually work. If they don't actually work, we can't use them. So, let's check our two solutions. Let's start with x equals 5. Now, if x equals 5, we're going to replace the x's in our original equation with 5. So replace the 5 here and 5 there. So we have log of 5 times 5 is log of 25. Log of 5 minus 1 is log of 4. Using the product property, this is the log of 25 times 4 is the log of 100. And the log of 100 is 2. Right? Log base 10 of 100. What power do I raise 10 to get 100? And that answer is 2. So 2 is a solution. It checks out. Or 2. It's not 2, it's 5. 5 is a solution. It checks out. When I plugged it in, I ended up with a true statement. So let's try negative 4. Just because 5 worked doesn't mean negative 4 won't work. All right, we need to check both of them. So we're going to plug in negative 4 into both of these guys. Now, 5 times negative 4, that's negative 20. Negative 4 minus 1 is negative 5. However, log of negative 20 and log of negative 5 are not defined. They are not defined. If we graphed them or tried to graph them, the calculator would freak out. If we tried to evaluate them, the calculator would freak out. They're not defined. They don't exist. Since neither one of these guys exists, negative 4 cannot be a solution. Alright. Now, that is the one example. The problems we're going to do are all very similar to those. What I would like you to do is to attempt the checkpoint problem on the back, or on your note guide. Now, attempt this problem. It's very similar to the problem we just did. You're going to attempt it and check your answers. In just a few minutes, you can walk through the steps because I'm going to put up the solutions. What I would like you to do is pause the video and work out the problem. Once you've worked out the problem, then unpause the video and check your answer. So here we go, pause the video. Alright, we're back and here's the solution. Now you can see we used the product property of logarithms to combine them. Once we did that, we exponentiated both sides, canceling out the logarithm. Then we distributed. Notice we're following exactly the same steps that we just followed. We distributed. We get x squared minus 9x equals 36. Subtract 36. We get x squared minus 9x minus 36, which we can factor into x minus 12 and x plus 3. So our solutions would either be x equals 12 or x equals negative 3. Now, if we were to check our solutions, we would see that x equals 12 does work. X equals 12 is fine. But x equals negative 3 does not work. So, there is our checkpoint question. The answer to log base 6 of x minus 9 plus log base 6 of x equals 2, the solution is x equals 12.